In order to find the value of the limit, we first need to recognize that we're dealing with the limit of a function, f of x equals 3x squared minus x minus 10 over x squared minus 4. Now we'd like to solve this limit by using direct substitution, but we can only do that if the function is continuous at the value the limit's approaching. And unfortunately, because plugging 2 in the denominator gives us 0, that means that the function is not continuous at x equals 2, and so right now we can't use direct substitution. However, because we're dealing with a function that has a polynomial in the numerator and the denominator, there's a chance that we could factor both of these polynomials and end up with an abridged version of our function where we can use direct substitution. So if we factor the numerator, we get 3x plus 5 times x minus 2, and the denominator gives us x plus 2 over x minus 2. We can then cancel out the x minus 2's, and we can then look at this abridged polynomial, this 3x plus 5 over x plus 2, and look at the limit of that as x approaches 2. Now this function is defined at x equals 2, there's no problem if we plug 2 into that denominator, so we can use direct substitution to find the limit. We're going to plug 2 in for x, and that's going to give us 6 plus 5 in the numerator, and 2 plus 2 in the denominator, which if we solve will give us our final answer, which is that the value of the limit is 11 over 4.